Evan, I heard you've been working on a side project. What is it about?
Oh yeah, so recently I've been trying to build this bot that learns by itself on how to play chess. And then so it starts off with nothing, and then eventually as it plays chess with more and more people and sometimes itself, it will become better and better at chess. But I've been just having trouble figuring out this very preliminary AI problem, and I'm kind of frustrated at it.
Oh no, what is this problem?
It's called the multi-armband problem. Have you ever heard of it before? I know it's kind of like a wordy term.
No, never. What is it?
Well, mathematically speaking, it's just when you're trying to estimate the true probability of a set of parameters, and using this estimate of the true probability, optimize a certain problem that relies on these set of parameters.
Sorry, I'm lost. I don't really understand.
Okay, yeah, fair enough. So imagine yourself that you're going to the casino, right?
Yeah.
And one of the things about going to the casino is that you obviously want to win as much as possible in the casino.
Mm-hmm.
And let's say you go to the slot machine section. You have a bunch of slot machines in front of you.
Mm-hmm.
And the thing about slot machines is that different slot machines have different chances of winning, right?
Yeah.
So let's say this slot machine has a 50% chance of getting a jackpot. This one has a 70% chance of getting a jackpot. They're all randomly different. But you as the gambler, you don't know that, right?
Yeah.
You're a player. But the thing is, on one side, you're trying to earn as much as possible. But you just choosing random slot machines isn't the best way to go about, because some slot machine has a low probability and some machines have the higher probability. And the most likely scenario is that you're worse off than when you started. So you gotta think smart.
Yeah.
You sort of need to kind of figure out which slot machine has the highest chance of winning.
How do I know?
Yeah, exactly. How do you know which chance the slot machine has the highest chance of winning, right? And at the same time, you're trying to win the most.
Mm-hmm.
You do it by just testing out the slot machines, right?
Mm-hmm.
So for example, if you test this random slot machine 10 times, and 7 out of 10 times it will give you jackpot, then you know that this slot machine has a pretty good chance of winning. And then if you do it for other slot machines, then you can sort of grasp a general idea of which slot machine is the best slot machine for winning, and then you just keep rolling that slot machine, right?
Mm-hmm.
Now that's the problem. To get a good understanding of which slot machine is the best compared to all the other slot machines, you just have to test random slot machines. You just gotta keep testing until eventually you become confident that, oh, this slot machine is better than the other slot machines. But then if you just test random slot machines, as I stated before, right, then you just lose money, because most of the slot machines will probably have a very bad chance of winning. And you just can't test random slot machines. So now the problem is, how do you balance between just kind of earning the best money right now, and at the same time just grasping a better idea of which slot machine is the best for winning the money through trial and error? And that's the two sides you're trying to balance. Because when you're trying to just kind of grasp a better idea of which slot machine is the best, you're wasting money in some senses. Yeah.
So if we want to win the most amount of money from the slot machines, we kind of need to balance between how much we earn right now and our knowledge to the slot machines.
Yeah, exactly. So there's two sides we have to balance between just earning the most out of the slot machine, because we want to play this game smart. So on one side, we want to maximize our earnings given all the knowledge we know right now. So we want to keep choosing the slot machine that we think has the biggest chance of winning right now, right?
Yeah, but on the other side, if we keep testing, then we are investing money into gaining the knowledge.
Exactly. So on the other side, maybe that slot machine is not the best slot machine to do. So we want to continue to test slot machines randomly. But if we just keep testing slot machines randomly, we're just wasting money.
Yeah.
So now we have two sides of the scale to balance, and that's our problem right now.
Oh, I
Exactly.
see.
Yeah.
So, but how does this relate to AI?
So AI is just a way to mimic human skills, right? It's just kind of a mathy way to be good at something a human can do. So for example, humans, to be good at something, to be good at, let's say, at programming, we have to train and practice programming. We have to take courses, we have to, just do a lot of practice, do coding challenges, maybe side projects. And eventually, through all these practice, through all these time and resources that we have committed, then we'll be good at this sort of skill.
Mm-hmm.
But the thing is now, what if these time that are wasted practicing and these resources could be put to us actually working at like some sort of company and actually getting the return, right?
Yeah.
But like, wouldn't that be better? Well, the problem is that if we don't practice enough, then we won't be good at what we do.
Uh-huh.
So now we have to kind of like draw a line between when do we stop practicing and we actually like work,
Uh-huh.
then and when should we practice? Because if we don't practice enough, we wouldn't work like effectively.
Uh-huh.
So that's sort of like what AI does. AI, similar to practicing, gets fed data. That's their kind of practice, and data can be costly. Yeah. So like for example, to our slot machine example, our knowledge about the different like slot machines, it's sort of our data because it helps us become more aware of which slot machine is the best, right? So we kind of become better at kind of predicting and just choosing the best slot machine. Exactly. So we kind of want to build an AI that, given the least amount of data to it, we want the best return. So kind of like a person. Like a good worker would be a worker that has little amount of training as possible, become the best it can possibly be at the job.
Oh, so
Yeah.
essentially what you're trying to do is making your AI be as good as possible at predicting, given the least amount of resources or data to train it.
Yeah, that's essentially what we're trying to do.
Mm-hmm.
Yeah, so like as little as possible data, and we want the AI to be a very, very exceptional worker that even with just a little bit of resources,
Mm-hmm.
it can still be a very, very like effective.
I see.
Yeah.
But how are you then going to solve this problem, the multi-armed bandit problem?
Yeah, so one of the ways to solve this problem is called epsilon greedy. Have you ever heard of it before?
No, sounds like a fancy term.
Yeah, it's sort of wordy. So basically, just imagine we're back in our slot machine example, and we've got a balance between just earning the most of what we know right now and just getting a better grasp of which slot machine is actually the best slot machine for winning, right?
Mm-hmm.
So let's say to do this, the epsilon greedy just simply means this. We flip a coin,
Mm-hmm.
and if we land heads on a coin, then we'll simply choose the slot machine that we think has the highest probability of winning or chances of winning. And if this turns into tails, then essentially we just choose a random slot machine, because perhaps another slot machine, if we just choose a random slot machine, perhaps that slot machine has a better chance of winning than our current slot machine. So we want to kind of like keep our eyes still open for any possible slot machines to have a better chance and just get a better grasp of all the probability of winning for every slot machine. Yeah, so it's kind of like a randomized choice between each of them.
Yeah, what is epsilon? What does epsilon mean or represent?
So basically, epsilon is just like a fancy term on how should we flip our coin in our example, right?
Mm-hmm.
So maybe we want heads to appear more often or tails to appear more often, because in our previous example, our coin is just like, half and half. There's a chance half the time that we'll get our heads and half the time we'll get tails.
Mm-hmm.
But maybe you want to get heads often, and in that case, then we can select our slot machine that has the greatest probability of winning, that we think has the greatest probability of winning, more often than just rolling a slot machine that is random.
Oh.
Yeah, but this is all like an AI model, so we just shift like this kind of number around and just play around with it. Yeah.
So epsilon greedy is a way to solve this multi-armed bandit problem.
Yeah, so essentially just flip a coin, and depending on what the coin is, then you would choose the slot machine that you think has the greatest probability, or just choose a random slot machine.
How are you going to implement epsilon greedy into your project?
Oh yeah, so basically in my bot project, right, I'm trying to make it to be as good as chess as possible.
Yeah.
But at the beginning, as like our bot doesn't know anything about like the current situation, so it has to sort of learn about what are the best ways of playing chesses, right?
Yeah.
So let's say that it has a pre-assumption that this is the best way of playing chess. But the thing is, what if there's another way of playing chess given this board, this scenario, like the board positioning? Maybe there's a better way. then in that case, on one side, the bot wants to win the chess game. So it will, on one side, it might play the best way of winning the chess game, but at the same time, perhaps there might be a better way. So it might, at sometimes, it will just try to explore a new way of playing it just by moving random pieces around. So yeah, so that's our epsilon. Like 50% of the chance, the bot will try to play the best way that it thinks of winning the game, and 50% of the chance, it'll try to explore another way, and maybe that way will be the better way of winning the game.
I see.
Yeah, and that's epsilon greedy.
Oh, thank you. I learned so much. Let me know when you finish your project so I can play chess with your bot.
Yeah, for sure, no problem.